Welcome to the DIY Honda Garage channel. The diagnostic trouble codes DTC P2237 and P2238 relate to the air-fuel ratio AF sensor malfunction. Specifically, these codes indicate that there is an issue detected by the Powertrain Control Module PCM connected to the AF sensor, which plays a crucial role in regulating and delivering the correct air-fuel mixture for optimal engine performance. The AF sensor, often referred to as Sensor 1, is typically found in the exhaust system, just before the catalytic converter, where it monitors the concentration of oxygen in the exhaust gases. When the PCM discovers an abnormality in the sensor circuit, such as an open circuit for P2237 or a general malfunction for P2238, it triggers a fault code and stores it in the vehicle's memory. This prompts the need for a thorough inspection and troubleshooting to determine the exact nature of the problem, whether it's related to the sensor itself, the wiring, or the PCM itself. This presentation will outline the detailed troubleshooting steps necessary to diagnose and address these trouble codes effectively. The air-fuel ratio AF sensor, specifically Sensor 1, is a pivotal component for monitoring engine efficiency. Located between the engine and the catalytic converter, this sensor gauges the oxygen levels in the exhaust gases. The PCM uses its readings to adjust the air-fuel mixture, ensuring the engine runs optimally while minimizing emissions. When the A-fuel sensor operates incorrectly, it can significantly impact performance. An overly rich or lean mixture can lead to engine roughness, poor fuel economy, or increased emissions. The DTC P2237 indicates a detection of an open circuit in the sensor's LAFCA circuit, which might suggest a gas concentration discrepancy that cannot be adjusted by the PCM. In contrast, DTC P2238 suggests a general malfunction of the sensor, indicating that the PCM has assessed the sensor's performance and determined it does not fall within its specified parameters. To properly address the issues represented by DTC P2237 and P2238, it's essential to understand potential causes. An open circuit in the A/F sensor means that the electrical path responsible for sending data to the PCM has been interrupted, which could be due to damaged wiring or poor connections. Additionally, a malfunctioning A/F sensor might fail to deliver accurate readings, leading the PCM to register a fault. This could involve wear or internal failures within the sensor itself. Lastly, if the PCM connections showing signs of corrosion or damage can disrupt communication between the sensor and the module, leading to erroneous readings or stored codes. Recognizing these faults is critical for a successful diagnosis and ensures that technicians can proceed to the necessary inspections promptly. Symptoms associated with DTC P2237 and P2238 can vary, but generally they manifest as rough engine performance, poor fuel economy, and increased emissions. A malfunctioning AF sensor can cause the engine to run either too rich or too lean, leading to irregular operation. This may include noticeable fluctuations in engine idle or acceleration stutters when driving. Additionally, drivers may observe a decrease in fuel efficiency as the engine struggles to maintain the proper air-fuel mixture. Furthermore, the vehicle might produce higher emissions, leading to potential failures during emissions testing. It's important to recognize these symptoms early, as they can contribute to long-term damage or inefficiencies in engine operation if left unresolved. The first step in troubleshooting DTC P2237 and P2238 is to start the engine and hold the RPM at 3000 without any load. This should be conducted in a safe environment, ideally with the vehicle in neutral. By maintaining the engine speed at 3,000 RPM, you allow for optimal conditions to engage the cooling system, as the radiator fan should activate during this process. This is a crucial step as it checks if the AF sensor is operating as intended under conditions that could affect engine temperature and performance. If the fan engages normally, the next steps will involve inspection of the AF sensor's functionality and its associated circuits. This initial check is vital in pinpointing whether the issue lies in the sensor itself or if it may be a further systemic problem impacting the vehicle's performance. The second step involves inspecting the AF sensor, Sensor 1, closely for any signs of damage or connection issues. This inspection should encompass both the physical condition of the sensor and its electrical connections to ensure they are intact. Look for frayed wires, corrosion, or any other impurities that might interrupt electrical continuity. A thorough visual examination can expose physical damages that might not trigger a DTC, but can significantly impact sensor output. Additionally, testing the electrical connector for continuity is essential to ensure that there is no open circuit or intermittent connection contributing to the malfunction. This inspection is key, as faults discovered during these checks may directly lead to rectifying the stored DTC. In the third step of troubleshooting, focus on validating the condition of the Powertrain Control Module, PCM. The PCM serves as the brain of the vehicle's engine management, receiving inputs from various sensors, including the A-factor sensor, and executing commands accordingly. Inspect the PCM for any visible signs of damage, corrosion, or other abnormalities that could impact its performance. Furthermore, using diagnostic equipment to confirm that the PCM's inputs and outputs are functioning correctly can help verify whether the processor is correctly interpreting data. Should issues be found at this stage, repair or replacement of the PCM may be necessary. This step is crucial, as a malfunctioning PCM can mimic the symptoms of a faulty A-factor sensor. The fourth troubleshooting step involves the installation of a known good AF sensor to confirm where the failure originates. By replacing the existing sensor with a confirmed functional unit, technicians can evaluate whether the problems associated with DTC P2237 and P2238 persist. If the malfunction still occurs with the new sensor, this would suggest an underlying issue likely resides with the PCM itself rather than the sensor. Conversely, if the issues are resolved with the new AF sensor, it confirms that the original sensor was indeed defective and necessitates replacement. This method of using a known good component is vital in effectively diagnosing and rectifying sensor-related faults in the vehicle. Final repair verification is an essential step following the troubleshooting process for DTC P2237 and P2238. Once the faulty component has been identified and replaced, technicians should clear the DTC from the Powertrain Control Module, PCM, to reset the system. After clearing the codes, it is crucial to perform a final test drive to ensure that the issue does not reoccur. During the drive, pay attention to the engine performance, especially under varying loads and conditions, to validate the effectiveness of the repair work. Additionally, any diagnostic tools used should indicate that no new codes have been generated during normal operation. This final verification step is critical to restoring confidence in the vehicle's performance and ensuring that it is functioning as intended. Preventive maintenance plays a vital role in averting future occurrences of DTC P2237 and P2238. Regular inspections of the AF sensor are necessary to catch any potential issues before they escalate into larger symptoms or faults. technicians should routinely check the integrity of wiring and connectors associated with the sensor and PCM, ensuring they are free from corrosion or physical damage. By cultivating good electrical connections and replacing worn sensors promptly, drivers can significantly minimize the risk of related trouble codes surfacing in the future. Early intervention is key in maintaining optimal vehicle operation and should be considered part of any proactive vehicle maintenance schedule. In summary, understanding the implications of DTC P2237 and P2238 is crucial for effective troubleshooting and repair of the Honda Civic 2022 Plus. The AF sensor's role is pivotal in maintaining an efficient air-fuel mixture, and any malfunction can lead to negative impacts on performance, fuel economy, and emissions. Following a structured approach to diagnose the issue, including inspecting the sensor, connections, and the PCM, ensures that technicians can accurately identify and rectify problems. Further, implementing preventive maintenance practices can significantly reduce future risks of sensor-related faults. By adhering to these guidelines, vehicle operators can maintain optimal vehicle performance while minimizing repair costs and extending the lifespan of critical engine components. Please like and subscribe to the channel. See you next time.